So start up for this week, we will be talking about circles once again. Number one, assume that lines that appear to be tangent are tangent. O is the center of the circle. Find the value of x. Figures are not drawn to scale. If a line that appears to be tangent is tangent, then we know that PQ is going to be tangent to circle O at point Q. So Q is our point of tangency. We're asked to find the measure of angle X. Now, why or how could we find that if angle P is 12 degrees? Well, if we pulled this out and drew it over here, angle 12, and we're looking for X, what do I know about angle Q? It's 90 degrees. Why? Because if a line intersects or a tangent intersects a circle at the point of tangency and the radius, then they are perpendicular to each other. So we have a right triangle. We're looking to find the second acute angle. So simply, 90 plus 12 plus x would equal 180. So x would equal 78 degrees. Next, question number 2. Find the value of x. If necessary, round your answer to the nearest tenth. The figure is not drawn to scale. If we have two chords, then their segments, or their pieces of their segments, if you multiply those two together, the products would equal the other two. So the product of the two pieces of a chord equals the product of another chord, pieces of the other chord. So we have 10x equals 120, x equals 12. So they have to intersect. If they intersect, then the product of their pieces equal the product of the other piece. Let's look at number 3. Still finding x. For number 3, 4, and 5, we're still solving for x. Number 3, we're told that AB is 20, BC is 6, and CD is 8. So those are the respective pieces. We're asked to find x. Now, a while ago, if the lines intersect inside, it's just the product of their pieces. However, if we have intersection outside, then we have to say the product of the exterior times the whole thing. I think we used the formula of previously saying outside times the whole equals outside times the whole. We're looking at the outside piece of 6 times the whole thing, so that's 20 plus 6. I'm going to write it that way so we can see it later. Then the outside of 8 times the whole thing, 8 plus x. So that's 6 times 26 equals 8 times 8 plus x. We distribute. So we have 64 plus 8x. Multiply 6 times 26. Is that 156? Now subtract 64. And when we subtract, we get 92. Am I doing my math correct? So then we divide 92 by 8. 11.5 equals x. Remember, the directions did tell us to round to the nearest tenth. Therefore, x equals 11.5. Number 4 and 5, still same direction, solving for x. Same directions as up here as number 2. Find the value of x, round to the nearest tenth if possible. Figures are not drawn to scale. Number 4 is multiple choice. Lucky you. Hey, the same process from the last problem to this problem. Outside times the whole. So we can say O times W equals O times W. the outside piece times the whole piece. If it's a tangent, I'm going to square it. That's essentially what I'm doing. Equals the outside times the whole. So I have to add 5 and 17. So then x squared equals 5 times 22, or x squared equals 110. We take the square root of both sides. So x equals 10 point, I'm going to jump out on a limb and say 49. So we would select B as our answer. It seems a little crazy that they told us to round to the nearest tenth, and yet all the answers are rounded to the nearest hundredths. But anyway, number 5. It's a little different, changing gears. Now, it tells us that NA is congruent to PA. That's important for us to know. Right there, by those two segments being congruent and knowing that MO is perpendicular to NA and RO is perpendicular to PA. So since those two segments are congruent and perpendicular, that means that I know RO is congruent to MO. Because if a chord going, if a line from the center of the circle is perpendicular and they are equidistant to two chords, then that means the chords are congruent. So we want to solve for x now. But we're told that MN right here is 6. What else are we told? Well, if a chord is perpendicular to a segment from the center, then it's bisected, so that means it's 6. Just FYI, MO is 12. But is that what we're looking for? No, we're only looking for x. If I know the whole thing over here is 12, then it's perpendicular from the center. That means it's bisected, so this side is 6. So that means that x equals 6. They are equal. Since I know that RO is congruent to MO, I then know that RP is congruent to PO, and those are both congruent to MN, which is congruent to NO. So all of these segments right here are congruent to each other. And let's finish up with number 6. If the measure of arc BY equals 40, so this arc right here, BY, equals 40 degrees. What is the measure of angle YAC? We want to know this angle, YAC. The figure is not drawn to scale. That is an inscribed angle. If I knew its intercepted arc, then I could divide it by 2 to find the angle. Because inscribed angle equals half of its arc. So how can I find the arc? Notice that we have a diameter. And a diameter forms a semicircle. So that means from BY all the way to A, that's 180 degrees. So how do we find this? 180 minus 40 tells me the measure of arc YA, which is that dashed arc in here that we were looking at. So that means it's 140. And what do we say? If the inscribed angle equals the measure of the arc divided by 2, therefore the measure of angle YAC would equal 1/2 of 40. So the measure of the arc is 70 degrees. And that is your startup for this week.